Alright, hello. In this video I'm going to show you how to use the TI BA2 Plus, which is their specific finance calculator. I think this will be relevant to other brands that have a basic finance calculator as well. Okay, so looking at this calculator, we're going to eventually use these white buttons to do the time value of money functions. But first, if you just bought this, there's some really lousy factory default settings we need to fix. 3 factory default settings we need to fix. Otherwise, you're going to get wrong answers, and the calculator is going to be a burden, not an aid. First one is, by default, this calculator rounds everything to 2 decimal points. Not just the display, it actually rounds it. So for instance, if you take 1 divided by 3 and it equals, you get 0.33. I mean, that's the hard number, 0.33. That's insane that it does that, because we know it's 0.333333, going on forever. So it's like 10% error right there. So we need to fix that. The most decimal points this calculator allows is 9, so we're going to set this to always show 9 digits beyond the decimal point. So to do this, you go to the second button, second, and then go to Format down at the bottom, which is above the plus, the period button, and then you can say it says dec equals 2. We're going to change that to 9, and then hit the enter button at the top, enter, and now it's going to round everything to 9 decimal points. Okay, so get back to the regular home screen. We're going to hit quit, so you need to hit second, and then quit, you can see is right above the compute key, and now we're back. So now when we do 1 divided by 3 equals, you see now we get a much better approximation of 1/3, 0.333333333. Okay, so that's the first thing we need to fix. The second thing we need to fix is, by default, this calculator does math in the wrong order. Don't ask me why, but if you do like 2 plus 3 times 4, 2 plus 3 times 4, like back in maybe 5th grade, you learned that you do the multiplication first, so you do the 3 times 4 first, 12, and then you add the 2. 12 plus 2 is 14. So 2 plus 3 times 4, let's type it in on this calculator, 2 plus 3 times 4, 20, right? Because it's just doing it ignores precedence of operators and it just does the operations from as you type them in, basically from left to right, ignoring precedence. So that's going to give you all kinds of grief unless you use the parentheses a ton, which you're going to make mistakes. So let's fix that. To fix this, we're going to hit second again, and we're going to hit format. And now you can see it says dec equals 9. We've already fixed that. Use the up or down arrow keys. Use that down arrow key, and it'll cycle through some options. And you want to get to the option where you see CHN. That's chain, I guess. I think that's the abbreviation. That's not what we want. So to change that, we want to hit the set button. Set is the above the enter key. So we're going to hit second, enter, and now it says AOS, and that's what we want. Now it's going to do mathematical operations correctly, following the proper order of precedence for plus and times and minus and divide and all, exponents and all that stuff. Okay, so now it's all good to go. We just exit out again, hit second, quit, and you're back to the home screen. So now let's do 2 plus 3 times 4 again. 2 plus 3 times 4 equals 14, which is the right answer we're looking for. One more thing we need to set, more finance specific, is by default it's going to assume like there's 12 compounding periods per year, because it's kind of set up for consumer loans where you get monthly car payments, monthly mortgage payments, things like that. The way I'm going to teach you in class with the notes is we're going to convert the interest rate ourselves to the per period interest rate, say the monthly interest rate given an annual APR. The calculator assumes everything's an APR compounded monthly by default, so we're going to switch that. So this time, we're going to hit second, and we're going to hit the PY button, P/Y, which is right above the IY white button. So I hit second and then the IOI white button. You see P/Y equals 12. It's assuming there's 12 compounding periods per year. So that's fine if everything you do on this calculator is an APR compounded monthly. But a lot of the times we're not going to be doing that. So let's just set this to 1. I want P over Y to be equal to 1. And then we're going to do the interest rate converting ourselves before we plug the interest rate into the calculator. So now we need to hit enter. Okay, and now we're good to go. So you can hit second quit. Okay, so those are the 3 things we need to switch on the factory default settings to make this calculator work the way we want it to. By the way, everything I just said is on the financial calculators page on Canvas. Okay, so now let's look through a couple quick examples here. We're going to do 2 lump sum problems and 2 annuity problems. So from the Chapter 5 slide deck, go to slide 19. So Chapter 5 slide deck, slide 19. Okay, so on this side it says if you deposit $10,000 in a bank that offers 10% interest per year, how much will you have in 2 years? Okay, so we're going to use, basically what we're going to do is use these white buttons, plug in the ones we know, and then we're going to hit solve, or on this calculator it's actually compute, the one that we don't know. Okay, so before you do any time value problems on this calculator, since different from the more fancy TIs where you can see all the values at once, we want to clear out the registers, the memory, that for the time value of money. And the way you do that, you see right above the FV key has CLR TVM, and that stands for clear time value of money memory. So you hit second FV, and now we've cleared out the interest rate, the number of periods, the present value, the payment, and the future value. Everything's blank and ready to go. Back to the problem, slide 19. We're going to deposit $10,000 today. So that's my present value. So I'm going to enter negative 10,000. Okay, I'm going to enter it as a negative because it's money coming out of my pocket. Remember, when the calculator or on Excel, we got to distinguish between inflows of cash and outflows of cash with positive signs and negative signs. So since money's coming out of my pocket, I'm going to call that a negative $10,000. And now, so that's negative $10,000. That's the present value. So I'm going to hit the PV button. You can see it says PV equals negative 10,000. Okay, the next thing we know is the interest rate's 10%. So I'm going to type in 10. And I'm going to hit the I over Y as the interest rate. Hit that, and you can see I over Y equals 10. Remember, on these financial calculators, you enter interest rates as the actual percentage. So I enter 10% as 10, not as the decimal equivalent like we do when we use the formulas in the slide deck. Okay, and then we want to know, so we're depositing $10,000, that's our present value, 10% interest per year. How much are we going to have in 2 years? So 2 is my N, or in the slide deck would be T, but N, T are similar, so N, hit that, N equals 2. And that's it. That's the data we know. We could put in 0 for payment. There are no recurring payments. You know, this is a lump sum problem, but since we cleared out the registers, it has a 0 in there already. Okay, so we don't need to explicitly do that. What we want to calculate is the future value. So I'm going to hit the CPT button, stands for compute, and then I hit the FV button, future value. You get $12,100, just like we found in class. Okay, that's our first lump sum example. Let's go to slide 34 in the same slide deck. And here we're going to solve for an interest rate. Okay, so I'm going to first, starting by clearing my time value money register. So I hit second FV to get the clear TVM. Okay, so now I'm starting from blank page. We're going to invest $1,000 today, and in 10 years, you will receive $3,000. What's the annual rate of return or interest rate on this investment? So I'm going to put in what I know. I'm investing $1,000 today, so I'm going to put that as a negative $1,000. Money's coming out of my pocket, so I'm going to hit that as the present value. In 10 years' time, so 10 is my N, 10N, I'm going to have $3,000. And this time I'm getting to $3,000. So I'm going to put that as a positive number, and that's the future value at time 3. And now I'm ready to solve for an interest rate. So I'm going to hit compute, I over Y, and the interest rate is 11.61%, consistent with what we solved for in class. Okay, so that's how you use this calculator to solve lump sum problems where you're just moving a single cash flow through time. When you use this calculator to solve annuity problems, it's very similar, except we're going to have to use the payment button as well, the PMT button. Okay, so let's just go through a few of those. So again, I'm going to clear my time value of money registers, second, FV. Okay, so now I'm starting from scratch. So for this example, go to the Chapter 6 slide deck and look at slide number 20. Slide number 20 in the Chapter 6 slide deck. Okay, and this says, you are the lucky winner of the $300 state lottery. You can take your prize money either as 3 payments of $100 per year, starting 1 year from today at time t equals 1. So you get your $100 at t equals 1, another $100 at t equals 2, and a third $100 at t equals 3. So that's a 3-year annuity. Or as a lump sum payment of $260 today. The interest rate's 10% per year. Which option should you choose? Okay. So, what do we know? Here, we know that we're going to get 3 payments. So I'm going to put 3 as my N. N is the number of payments in an annuity problem. And then, let me see if I can get this a little bit lighter too. There we go, it's a little bit better. We know the payments are $100 each, so I'm going to be getting $100 at year 1, at year 2, at year 3. That's the payment. So I'm going to hit the payment button. And then we're assuming the interest rate's 10%. So I'm going to enter 10, I over Y. Okay. In this case, we're going to solve for the present value of those 3 payments. We're not going to use the FV button now. It has a 0 in it right now, and that's fine because 3 years from now, other than that $100 payment, which we've already accounted for, nothing's happening. So we're just going to not do anything with that, or you could enter 0 FV if you wanted to. When we get the bonds, we're going to use all the buttons. We use future value, payment, and present value, all 3. But for now, we don't need to. So what I need to do is I need to compute the present value. So I'm going to hit CPT, PV. And you can see the present value. It says negative $248.69, same as the slide deck. All that negative means is, I'd have to deposit that money in the bank account today to get the $100 payments 3 years, one over each year for the next 3 years. So just, put some, interpret that negative sign. But the present value is $248.69. That's less than the $260 lump sum payment, so I'd be better off with the lump sum payment of $260. The second part of this problem says, what if the interest rate's 5%? Okay, so I don't need to clear out the TVM registers. I already have the right N, I have the right payment. All I need to do is put the right interest rate, which is now 5, and hit I over Y. So I change the interest rate to 5. I still have N equals 3 in there. I still have payment equals 100 in there. So now I can compute the present value again. You can see now the present value is $272.32. So in this case, if the interest rate were 5%, I'd be better off taking the lump sum. I'm better off taking the annuity, which has a present value of $272.32, over the one-time payment of $260. Okay, so that's the example from the slide deck. We're going to go one step further. So we saw that if the interest rate's 10%, you're better off taking the $260 today, because the present value of those of the annuity is $248. If the interest rate's 5%, you're better off taking the annuity because the present value is $272, which is better than $260 one-time payment. So now the question is, what interest rate makes you indifferent between a lump sum payment today of $260 or 3 annual payments of $100. So what we're going to do now is solve for the R. So I already have N in my calculator, N's 100. I already have the payment in the calculator, that's $100. So now I'm going to enter 200, negative 260, because I have positive payments, positive 100 for payments. So I'm going to enter negative 260 for the present value and hit PV. So now I've entered N, 3, present value, negative 260, payments are positive 100. So now I'm going to compute the interest rate. You can see the interest rate that would make me indifferent between those two payment options is 7.51%. So at 7.51% interest, the present value of those 3 annual payments is exactly equal to $260. Okay, so that's how you can use the financial calculator to solve for R. And that's it. BA2 Plus, cheap calculator, it's about $30. Does some pretty heavy lifting math as well. It does fancier stuff as well, but that's all I'm going to cover in this video.